Hello, we are the group 19. Today we will present our design project, the virtual city. In this video, there are mainly four parts. The first one is the terrain design, followed by buildings and environment system, traffic and path generator, and the final is the weather system.
Okay, so what I'm going to do is I'm going to quickly go over sort of what I worked on this terrain generator. I'd also been doing some work on UI, although I haven't been able to implement that fully. So for the purpose of this demonstration, I've just cut it out. So this is the terrain. So this is some generated terrain. So like hills, valleys, not too deep. So I'll bring you actually to the section where that is done. So the reason why it's not super hilly is I've set the max height to 70 and the min height to -20. Keeps it relatively flat, which I think is going to be more useful for our purposes, because you have too many hills. It makes it harder for us to place buildings and roads on here. So yeah, so this is the thing. I'll refresh the page so you can see it's different. Refresh it again. So this is a tester. It's pretty basic. Just gonna set up a skybox. So the water color here, and then we've got the generator with just a grass texture. So I'll actually go over the terrain itself. So using so we're using this library 3.terrain. So it gives us a couple things that we can do. So you just make a new terrain scene, 3.terrain, and then you can set some different parameters. So easing, different types of easing. You've got, I believe you've got linear, ease in, ease out, ease in, out. Those are the ones there. I'm just doing linear because I think it looks the nicest for what we're going for. And you got the height, and then frequency, and then height map. Height map's the other sort of big one. So the big ones for sort of how it looks are the type of easing, the height map, how many steps, and the max min height. And then the segments change things a little bit, but that's a little bit more basic. So this is at the diamond square. Some of the options include purlin, sign, diamond purlin, which is a mix of diamond square and a purlin generation for the terrain. I'm using diamond square for this right now just because I think it's good. Eventually, when this is fully implemented, and all of the UI stuff and is in there as well, and the user's able to adjust the height maps. We'll have a selection of maybe 3 or 4 height maps they can pick from. Probably I'm going to use all of them that are available because some of them are just a bit more hilly, or the distributions aren't quite good for what we wanted to do. So probably have 3 or 4 of them when that's fully done. Yeah, and then max min height. I'll adjust that just so you can see what it looks like. Save that. And we'll reload. Alright, so you can see it's a little bit more hilly but deeper here and there. So we'll probably also allow users to adjust that as well. But we'll probably keep it within specific parameters. Might also have it so they can only adjust the max height, not the min height, just so it doesn't change as much. And steps, I'll show what that looks like. As the steps get higher, it basically applies the sort of height map transformation, the height map calculations multiple times. This gets pretty dramatic, very rapidly, as you can see here. Once you get to sort of higher numbers, like around 20, so it begins to ease out a little bit more, but still we're probably just going to leave it at 1, just because that's because we kind of want the terrain to be largely flat and like not too dramatic. Yeah, so that's what we've got here for this. All right.
Hi, my name is Leo. I and Felix are mainly responsible for the building environment system and the traffic path generator. As the relationship between these two parts are really close, so we work together. Now we will introduce these two parts. As you can see from the video, the map size can be adjusted by map X and map Z. It can be adjusted by GUI.
The map has been divided into 4 parts based on the point in the map, which is selected randomly. While by using recursive algorithm, these 4 parts will be divided into more smaller area, so that we can get the specified path area and building area. Now basic data of map has been complete. Now we need to illustrate more specific detail about the small path and building areas. So we transfer all the path and check whatever the surrounding are path. For example, if there are more than 3 paths surrounding on the original path, there is the intersection. We use this method to allocate all area and also build up to the building and paths. After that, we load all the method to specify point of path to create whole path network in the map. Based on that, we establish a simple traffic system on the path. Meanwhile, we have an array of cars, which includes the position and its direction, as well as an index of connect with the mesh. There is also a mark to record whatever the car is moving or not. We also initialize the car and we randomly select contain amount of points to load the model of the car. Then we link the data of the model with the array of cars. We set an available direction to the car randomly and check whatever is reachable. As for the animation of the car, we move the initial position of the car mesh to the reachable point, and we mark the car as X moving. This can reduce the calculation to low of the project. When the position of the car mesh is equal to the position of destination, and we change the position of the car into the position of the destination, and then we set the new direction of the car, the process will be updated continuously.
For my part, I mainly work for the building system, as we have already allocated the path areas and building areas in the map. We need to specify more data for the buildings, as the current building areas is a whole group, so that we need to separate them into small parts to load the single model of the building. Meanwhile, we establish an array of buildings, which stores the size of the areas and the categories of the buildings. As the building areas has been divided by the path, so we can set the buildings in one area as a whole group. Firstly, we traverse all the maps in the map array, and we check whether the surroundings of one specific map has been defined. If it has been defined, we follow the building ID of the surrounding map and increase the size of the building area. If it has not been defined, we create a new building ID and link it to the map. After that, the building areas has been established overall, and we still need to separate the building areas into small parts to illustrate more details of a single building. And then we traverse all the building array. If the size of the array is too large, then we separate the array into 2 small parts. We repeat the process until all the suitable building array have been created. And this process will help us to produce a better shape of buildings. Then the next step is to combine the terrain system and the map system together to illustrate various buildings with different attitude. After that, we load the building models into the map according to the attitude of the terrains and the building array.
Like the rain, we have created the scene, renderer, and camera first, and we have used the same libraries. And we have also loaded the texture and by var loader and loader.load. And we have also created the geometry for the cloud and created the material in this line. We have also cloud geo and cloud material. We have also created the animation in function animate and in the function. So in this way we have created this cloud. For the rain in our virtual city, I have created the environment first, the JS, 3JS, then 3.min.js, and other resources and libraries. So here I have created scene, camera renderer, and some variables, which is very essential for rain. I have created rain geo, which means the rain will be in different random position, and I have also added the geometry with that line. I have also added the velocity by raindrop.velocity, and for rain I have also created the material, rain material, which is equal to new 3.points material. And for the as it is rain, so it needs to be reset its position. So in function animate, I have created that animation, and whenever the velocity the rain will be falling down, maybe it will end, that there will be no more rain. So I have created the loop and animation so that there will be the flow of rain all the time. I was planning to do some .gui JS, and I have also added the library, added the scene, camera renderer, and a light. So the light will be the sun, which I'm preferring the point light source among the ambient and directional light. So after the point light, I was doing some animation, like it will rotate every time, and user can also change the brightness and intensity of the light using that .gui system. Let's talk about the sunny weather. We have created the environment first. We have done and add the libraries like the 3JS and 3module.js. Then we added camera, renderer, and scene, and obviously the mesh. For this one, I have fitted the plane geometry, and I have also added the texture, which is a sunny picture. Then I have created an animation by a mesh rotation in y-axis so that the image will move a little bit right side. Welcome to our virtual city. I am Sakib Shahid Omi, and I have worked on the weather system for our group project. I have worked on rain, sun, and cloud, and some indirect system. I have coded the sun and the rain, but I have to now apply it in our group project. For the cloud, I have to add more features so that the user can interact more. For the .gui system, I am planning to do something like user can increase the brightness or intensity of the light, or they can control the rain, and this type of features. And I am coding right now, and I have some unfinished code, but hopefully I will do it on our group project. With no more delay, let's enjoy the video, and I will explain everything part by part. Thank you.